Hello, YouTubians. It's Kurt Marler here again. And this video is for technology teachers or parents who want to understand how our technology classes work. What I use with my technology students, which is robotics and computers, is NASA. NASA has made some pretty amazing things happen, and they've had some pretty large failures. And so that's important in engineering to understand where failures come from and what to do about it. The greatest story I can think of is the Apollo 13, where they went to cycle their oxygen cylinders. They blew out through nobody's fault, and they had to make essentially a rebreather. I'm a scuba diver, I'm a technical diver, and I do own and use a rebreather, so I understand the principle of it really well. But the main point is here they are stuck in space and they need to do something to make it back home. That happens with my projects sometimes. I have a book that I've compiled of robotic programs using the NXT. And because they're changing the system, sometimes it works, sometimes it doesn't. The NXT is being phased out for the EV3. Pretty smart move on their part, I think, because you have one robot that can do it all. The problem is NXT has been around for a while and they've gone through several versions and several parts. So here is the project that I gave them, and this is called the Spider. You can see it's page 74 of 562 in my book. That includes one motor and some gears, and basically you offset the gears or the crawlers on the gears so that it puts one foot in front of the other and walks over the surface. Now, as we did this, the gears, well, some of the pieces weren't available in these kits. They were older pieces. And then as we assembled it, we found out that the gears that they used to use are a different circumference than the ones we currently use. Therefore, when they assembled this whole thing, the gears were binding up and it wasn't working. So I approached my students with it like I normally do. I said, hey, guess what? You all did the build. It doesn't work. Welcome to NASA. Okay, welcome to engineering. That happens in engineering a whole lot. You expect something to happen and it doesn't. So what do? Mars rover's gone. It's over at Mars and it's doing something you don't want it to do. You better do something because billions of dollars went into this and people don't just want to have a chunk of robot on a planet that's not doing its job. So here's an example. I told my students, make something that acts like an insect. If you watch an insect, one of the things that it does the best out of everything is it crawls. And it'll crawl over anything. It doesn't matter if it's a pile of dirt, a pile of bricks, up a wall, up a curtain, across the floor, it doesn't matter. So I said, to the best of your abilities, create something that crawls. So here's what one student did. What they did is they made, excuse me, a little robot using the existing gears, the existing drive unit, and I told them to offset so that while these tires are touching, these tires are not. And then offset this way so that while this tire is touching, this one is not. Therefore, you have kind of a four-wheel drive crawler. Now, what's interesting about this build is that you notice there's no NXT brake or brain on this robot. The brain is attached via a cord that they had to program using the buttons that are on the robot to make it do something. Right button makes it go forward, as you might be able to see by the little arrow here. Left button makes it go back. Center button makes it stop. So here we go. Now, as you may see and judge, it is not pretty. But what insect is pretty? If you look at most of the robotics that are successful, they're not pretty to start out with. And I teach my students, what comes first is the engineering. Some idea that is made into a reality that works. You want something to crawl over it. Now, later on, no pun intended, if you work the bugs out of it, you might want it to be prettier. And that's how we get commercially available toys that do certain things. Quadricopters now are pretty, unlike the ones that are still being made at home by people and being programmed with using Raspberry Pis as a cellular receiver and controller unit and GPS receiver as well, tracking. They're ugly. They're held together with duct tape and screws and, aluminum foil. But they work. And that is what starts the process of making a viable product where somebody goes, ding, light bulb, hey, somebody might want to buy this. So, as encouragement for you future technology teachers, current technology teachers, any teacher, if something doesn't go right, don't scrap the idea. If something doesn't go right, don't have a fit. Don't let your students have a fit. They're sometimes disappointed because they just want to follow the steps A, B, C, and get a grade. My students were happier today than they have been in weeks because I've given them the freedom to build. And their final exam is going to be to build a robot to fight in a ring with other robots that's autonomous. They cannot touch it once they hit start. Last year, I made them clap to start their robot, so they had to use a sound sensor. They loved it. Everybody clamors for it. It has built a reputation. That is something that started from a failure. Okay? You made a robot and it didn't work the way you wanted it to. Pretty soon, I have a whole class of, a team, 8 teams of kids who are building robots that are going to not only climb over obstacles, but now they're going to climb better than each other. So there's competition. You have collaboration with competition. That's what you die for as a teacher. These students, I can't show you the one that one of my students, Caleb, did because it's sealed away in a box and I put a piece of tape over it that says, as per Mr. Marlar, do not open, because he did a monumental build. Now, because of that, there's going to be a monumental failure because we don't have a slip drive that we can incorporate into the system. I told him another way to go about it, and it's okay, he will, but his build was ingenious. By the way, he is one of the 2 students that I've recommended for a science symposium that happens in Washington, D.C., where they go for 6 days and they discuss technology in the future. So I hope to goodness that one of my students gets accepted because the 2 that I put in for this are really deserving of it. So, turn those failures into something that's challenging, something that makes them think for themselves. I did not tell these students how to do these builds. They will come up to me with an utter failure and I'll say, hey, you notice your leverage point is here. That's why this gear is falling off. Try moving your leverage point back a little bit or something like that. By no means am I a great engineer, but here's what I teach, So the best thing I could teach them is to think for themselves. And not only are they thinking for themselves, they are doing it highly successfully. So until next time, keep them happy.